So hello and welcome to SELGRA webinar number 6 already the second one actually in 2021. My name is Jeremy Rabino. I'm the president of SELGRA. And for those of you who don't know what SELGRA actually is, we are the student chapter of the European Low Gravity Research Association. And we aim at building a community of students interested about altered gravity research. So among our activities, we organize events just like this webinar, but we also have, for instance, a newsletter where we share with you the last updates in our field, as well as the current opportunities, PhD offers, summer schools, etc. Usually, we also offer grants twice per year for you to attend and to present your research in conferences. However, you can imagine that at the moment, it was difficult to give you these grants because all the conferences were canceled because of the coronavirus, but we hope that soon we can give you again this opportunity. At the moment, we have two additional opportunities. The first one is in partnership with LIDE to perform parabolic flights on a glider, but I will not give you details about this because our speaker will do this far better than I do. And the second one is called ELGRA Goes Suborbital, so right here. And it gives you an opportunity to put your experiment on board the New Shepard rocket for a suborbital flight, offering around 3 minutes of microgravity. So the deadline on the screen right behind me is not correct. It has been extended to the 21st of February, actually. So before this, I really encourage you to apply. If you are students and want to apply to SELGRA, it's absolutely free. So we'll give you the link to register in the chat if you want. But before that, let's go back maybe to our webinar. Just to give you some general information, we will ask you to keep your cameras and your microphones off. If you have any question, please ask them in the chat and we'll be our best to just answer them at the end of the webinar. Which should last around 1 hour and will be recorded. So that at the end, it can be made available on our YouTube channel. So today we are very happy to organize this webinar because we know that platforms to perform experiments in microgravity and hypergravity are not always easily accessible to students. And it's also what the guys behind LIDE's project have noticed. And they have decided actually to launch their own altered gravity platform using gliders. And today it's Mohammad Iranmanesh, LIDE's Chief Technical Officer, who is going to tell us everything they do to offer microgravity conditions with gliders that you can fly your experiments. Mohammad is an aerospace engineer with a diploma from UC Louvain in Belgium and ISAE Super-Héros in France, as well as a certificate in management of innovation from HEC Paris. He is an expert of space systems and has already led the technical work of many projects for ESA. And right now, he is not only the co-founder and CTO of LightSpace, but also the national point of contact for the Space Generation Advisory Council in Belgium. So Mohammad, we're really looking forward to hearing your presentation. And now the floor is yours.
Thank you very much, Jeremy. Thank you for the introduction. And hi, everyone. Yeah, so I'm Mohammed. I'll be talking to you about microgravity and what gliders can do. So let me try to share my screen. Here we go. Okay, I think you guys should see my screen if I'm not wrong. Yes, is it okay? I think it is.
Yes, it is.
Okay, thanks. Yeah, so LIDE is actually stands first of all for glide without G. So that's where the name comes from. And what we are, with our nonprofit based in Belgium, and really a startup initiative where we want to provide a parabolic flight with gliders to all kind of people, to student, to research organization, to startups, to anyone who wants to test something in microgravity. And I'll be talking about this new platform that we've been working on for more than a year now. And then at the end, tell you as well about a call that we have going on. First of all, even though I think many of you might already know about research in space and microgravity, let me just with this slide introduce the concept. So as you know, there is a lot of in a scientific field, you're looking for a lot of data points, and sometimes you want to see how phenomena and mechanisms, be it biological or physical, work, and how they behave in microgravity environments. So you want to have that data point at 0G. And there's actually microgravity research has a big place in science right now. These are just some of the ideas for applications. So in fluid dynamics, for example, we all know that fluids behave very differently when they're in microgravity. We've all seen videos of people on the ISS trying to shower or drink something. We also know that the interface between phases it behaves very differently for what we have here on Earth. So really a lot of reasons why we should be focusing on science in microgravity, and that's why there is a need in the scientific community for data point in those environments. In physics as well, there is a lot of physical experiment which are looking to get rid of a lot of perturbation, and going into microgravity kind of helps them get some data that they don't have access to in normal environment on Earth. Obviously, material science, we're always trying to see how materials behave in microgravity as well, in general in altered gravity. So there's a lot of need to just see how mechanisms, phenomenon, processes, or materials behave in when the gravity level is different than one, basically. And there are different ways of doing that on Earth. So one of the most basic way of trying to get rid of this gravity vector is to use something called like a random positioning machine, for example. What this does is that it would just rotate in a random way and alternate basically the direction of the acceleration vector. That way, you're going to have an average, because of all the random direction is going to cancel, all the vectors are going to cancel each other. So you can already see here that, yeah, you can get some scientific data here with even something as basic as this RPM machine. But it really, you can already get a sense that it really depends on what it is that you're trying to see. So if the phenomenon that you want to measure or observe has a time duration that is relatively slow, then yes, you could use this type of machine and average it over a long period of time. And the type of experiment that are used here, for example, is to see the impact of zero average gravity on cell growth, for example, or processes that are very, very slow, and you can use machines like that to already get some information. For the other platforms that you have based on Earth, if you want to have try to see what happens when you are in low gravity or zero gravity environment, one of them is a drop tower. So this is the famous tower in Zarm in Germany, where they just basically take your experiment and then they just let it drop. The free fall is about 9 seconds, and you can do some testing there. Maybe more likely to be known, so sounding rocket. So this is just basically a ballistic trajectory. You just launch your experiment, it goes up, and it doesn't. So these rockets are not powerful enough to go in orbit, but you're just going to have a ballistic trajectory and come back. And during that part of the trajectory, during some part of it, again, you're going to be able to experience low gravity. Parabolic flights, and here you can see the zero-G aircraft from Nova Space. This is probably one of the most famous one. That, yeah, you can do with parabolic flight. You're going to have some section of your flight which is going to be in microgravity, and a lot of people use these to do testing. So what we were doing at Lightspace basically is that we were looking at all of these platforms. We see that obviously there is tons of them. So sounding rockets, parabolic flights, drop tower, clinostats, it's another name for the RPM machine. And then we look at the criteria. So, okay, so if I'm a customer, what I would be looking at? I would be looking at the cost. Obviously, some parameters that is very important, as I said, is the duration of that weightlessness, the quality of it, like how accurate and repeatable you can get to that level that you want. And then really, so versatility, which we try to define it as basically how easy it is to try different type of experiment. For example, like some of them are going to be very limited if you have like if your experiment needs cryogenic temperature, some of them you could run it, some others would, for safety reason, you couldn't bring with yourself, like, I don't know, 100 liters of liquid nitrogen with you on aircraft, for example. So they each have benefits. They each have some limitations. And when we were looking at a table like this, so this is very just, an attempt from us at qualitatively looking at the existing ways of accessing in microgravity from Earth, basically, without sending something to space, because you know how much it costs to send something in space. Even though the cost of launching to space is decreasing, it's still a lot. And so that's why we came up with the idea of, okay, why not use gliders? So gliders are going to be much lower cost than commercial airliners and those commercial groups. The big problem with those big facilities like the ZARM Tower or No Space or the Zero-G Air Flight is that you have to, you can't just access them right away. You're gonna make your request, and it's gonna take really months, if not years, to get to be able to do your experiment. And also a lot of documentation that you need to have. So we thought, okay, if there is a small platform that fits a glider, then we could do those parabolic flight at lower cost. The lead time is going to be much lower because we are it's so easier for us to go somewhere and fly an experiment. We can go anywhere. So one of the challenges when we were talking to early in our market study phase, that basically a lot of people have experiment, and there is a lot of paperwork involved in exporting a scientific experiment to another country, or also maybe you just it costs a lot as well to go to another country to do a set of experiment. So with the solutions that we have, we basically started to have a network. We aim to have a network everywhere in Europe where we could just bring our pilots and our experiment rack to a glider basically close to you, and that way you could fly there just next, with the closest aerodrome to your lab or to your startup. It also, because you're going to have something which doesn't have a lead time, a much shorter lead time, and it's not that expensive, you're really opening the access to microgravity testing and microgravity science to a bunch of new players and stakeholders. So for example, if beforehand startups now who are working on some mechanisms, which we need, if you want to send people to Mars or to the moon, we need to be able to test a lot of things iteratively as part of the design process. And right now, startups do the best they can, and then they just send it to space, and they try to and they hope that the mechanisms or what they're trying to accomplish is going to work in microgravity, and they don't test it as much as maybe they could. So this way, by just doing some prototype, testing them, and then reworking on the prototype, it's really a new way of designing that they didn't have access to, even on the technology side. And then, a lot of students and labs who, again, because of the lead time and cost, didn't have access to those other platform, they can use gliders to test their experiment. So this was the idea and the vision, and what we've done, the first thing we did is, okay, we looked at, is that possible or not? And there has been some work that was done previous to when LIDE space arrived. So already in 2017, there was a paper, and basically what they did, you just flew with a glider, and they said, without a lot of quantification or characterization, but they said, okay, it looks like you can get about 6 seconds of 0G. You're going to have a hypergravity phase, obviously, as we expect with parabolic flights. And we, based on the trials, they found out that you can get, a relatively good weightlessness levels of, 0.001 G or 0.1 G. And you can have a bunch of, because a parabola with a glider over an hour flight, you can have a ton of parabolas, and then you can refly it again, the same day or just the day after, which is not possible maybe with the other platforms. So basically, they said, okay, it looks like it's promising. So we looked at this paper, and we were quite excited, and we tried to do our own measurement. So first thing was to come up with our own system to measure and really start systematically characterize the performance that you can get with a glider. And we had a couple system, one which was based on a Raspberry Pi and the other one on an Arduino. And really the idea was, okay, let's go and do proper measurement and characterize the level of acceleration that we can experience in all three axes when you're on a glider. This was our flight recorder prototype. We finalized the design, we built it, we put it on a glider, and we flew with it a few times, and we came up with some very interesting results. So just to give you an idea of where the prototype was placed, it was actually on, so you're using a two-seater glider. This is the ASK-21, and we put it on the back seat, basically. And this is the type of result that you can expect. So you can see on the left side, it's the altitude. So yeah, we went high enough, and then we started giving it speed, and it goes down. And every time, so you do this parabolic, you follow this parabolic path, and you can see that you can make a bunch of them. And every time you do it, so this is on the right side, you can see the load and the G levels basically. And you can see that every time you have about 6 seconds very close to 0G for each of the parabola. At the same time, you're going to have a spike of, so this was the first attempt. We had a spike of about 4Gs, and this was quite repeatable. Let me show you a video of what it looks like. So you can have, should work now, hopefully. Yeah, so that's basically the first test campaign. We put our flight recorder in it, and then you can see those. It's a glider. It gains altitude, and then you start this process of going up and down with the glider. It's a lot of fun for the pilot, and then obviously, so at this point, there is no experiment in the backseat, but just the flight recorder. And yeah, so you can see you can do a bunch of them. Every time you are doing a parabola, you are actually losing some altitude. But as you could see on the chart, you can do 7, 8, 10 of them. So we started actually quite low. We've done other flights where we started even higher, and you can do about 15 parabolas, for example, during an hour flight. And really, this is what makes it interesting, is that even though you don't get maybe perfect 0G, and maybe you don't get perfect 0G, and maybe the duration is not as long as others, but because you can get those, you can increase the number of parabolas that you make during a flight, it can actually be very valuable for a lot of applications. So as I said, the point of our flight campaigns were to quantify that and to characterize it, and we did that. And so we actually were able to measure it, and so you can see the statistical spread. You can see that they're relatively repeatable. You can see that the standard deviation is quite small, and the aerodynamic drag, because what gliders do well is fly and glide, which means that they're really good at having an almost having an amazing lift to drag ratio. So you're not going to feel this actual drag that much. The parasitic acceleration in the x-axis is not going to be that much of a problem. But you can get really below 0.2G, mainly about 0.1G, and then as I will explain later, it really depends on the pilot as well, and it gets better and better. So we are getting better as well. About 5.5 seconds with around 6 seconds of dip into 0G, and really so when you look at this, it's very interesting values and interesting platform, and that's why we thought, okay, this is something that we have to go for and try to bring it for people, because something else that you can do here, actually by controlling the path, the pilot can by changing some angles and some characteristic of the flight path, and that was also one of the reasons why we have designed this flight recorder, because on one side it's recording all this data, but also what it does is that it's displaying what the pilot should do. So it's a help for the pilot to follow almost the perfect path, so that we get the result that we want. So what you can do with this type of parabola is that you don't have to go for 0G, actually, by controlling your speed, and also and when and how you are going into the hypergravity phase, you can actually try to have an average phase of acceleration, which is going to be closer to, for example, like moon gravity, which is 1/6 of Earth, or even Mars gravity. So you can have those intermediate data, which I know for people who are in SELGRA and who are already involved with microgravity research, you know that, okay, it's good to have your data point at 0G, it's good to have your data point at 1G on Earth, but you really want to have some intermediary data point as well to kind of, improve your models. So this is something that we can do because our gliders are going to have a feedback from our flight recorder. We also looked at the jitter. So jitter is kind of is the parasitic acceleration and the vibration that you're going to have. And what we did is that we compared that jitter level to what you would see on an aircraft, on a general aviation aircraft. So with a propulsion system, with motorized, and you can see that our vibration levels are going to be actually lower. A bit lower. So some applications are going to be very sensitive to that parasitic acceleration that you have in other platforms as well. And we see that here that basically we managed to demonstrate that the gliders can be a much smoother.
Mohammed, I think you just muted yourself.
Okay, did I mute myself 10 minutes ago or just now?
No, 15 seconds
Okay.
ago.
So I was just saying that we managed to demonstrate that you can basically get a much smoother flight with a glider than with a general aviation aircraft, and that was something that we also wanted to show because you can have parabolic flight with other smaller aircraft as well, and obviously gliders are going to be cheaper to operate and maybe easier sometimes. But it's also important to know that if you're very sensitive to the jitter and to parasitic acceleration, the glider can also be a very good solution. So now we get to the payload size, and really the idea for this was that most of the gliders, there are a lot of gliders which are have a two-seater design. So we have this whole seat on the back where you have room for usually another passenger or the instructor, but also you could use it to put the payload. So this is just to give you an idea of the levels of mass that you can have on for your payload on a glider in total, right? So this is not what we were offering, but because basically it's designed and built to have someone sit there, someone who can be quite massive himself. So basically you have a lot of margin to put something there. In conclusion, so quickly to go, it's not the conclusion of my talk, but just the conclusion of this phase of analysis that we did. So we managed to do we did a lot of characterization flight, and we found that, okay, gliders can offer up to 6 seconds of weightlessness. You can go below 0.1 Gs, which is great. The recording are not going to be suffering from the vibration that aircraft with piston engines have. The back seat can accommodate a lot of massive. Has room for something quite heavy. A typical 20-minute flight allows you to realize basically maybe up to 15 parabolas. So this is what the pilot sees here. So I showed you before the flight recorder, and the pilot has an indicator like this, which tells him if he has to push or basically control its pitch during the parabolic phase and get the perfect path. And we also had this qualitative market study of seeing like what was missing. And so all of this is detailed in a paper that we have written and we have presented at the IAC conference in Washington, and we also published it. So I'm sure Camille from the Lightspace team can send you the link. Otherwise, if you're interested, you can go on our website, so light.space, and you'll find the link to this paper there, and you have all the technical information about what is possible with a glider, the quantification and characterization of that flight in terms of acceleration. then the next step for us was really to see, okay, now that we know gliders can be a good platform because you can get those 6 seconds of 0.1 G in a very repeatable way, it's going to be cheap to operate and it's going to be very easy to fly. What can we do to make it even easier for our potential customers, or students and associations and startups and companies to come and use this platform? So what we thought we would do is that to build an experiment rack. This experiment rack, what it does is that we're not going to tell people to come come with your experiment and come with your own housing. We're not saying come with your own power supply or data recording or microcontroller or data communication. We're building the full infrastructure. So we've designed and we actually built already and tested and flew the full rack. And what you have with this rack is that it's a standardized way of payload. So in this rack, it goes in the back seat. And what you come with is basically going to be something like a CubeSat. So it's a concept that's very similar. So you come with a standardized box, which has standardized dimensions and also standardized interface, both mechanical and electrical, for power at the same time as data. And then it's going to be very easy for you to then integrate it in our box. And we don't need, a lot of, and what we do is that we close the box. It's going to be hermetic. It's safe. We've done all the risk analysis, and you can just fly your experiment and be sure that you're going to get the data that you want very easily. And it's going to be very cheap with very little paperwork involved for everyone. And the idea of our experimental light box is that it's going to be about these dimensions. You can have two choices of power, so either 5 volts or 12 volts. You can get the two different level of current if you want. There's going to be a microcontroller with a bunch of input and output that you can use to control your experiment. So you either come with your own thing that you just fit inside the box, or you can use this microcontroller. What this microcontroller does is that, first of all, it's going to record all the acceleration data. So you know exactly at which timestamp you had which acceleration level. And you can either just use this timestamp later, and compare it. For example, if you have a video camera inside the box and you're looking at, let's say, a fluid interface, you're just filming it with the same timestamp. And then later you can sync the data from the accelerations that were measured and recorded by our system with your video feed, for example, and then try to do those analyses like that. Or you could, for example, program it so that it does something inside your box at specific time. So if you want to say that every time there is microgravity or G levels below 0.3 G, I want it to turn a lamp on, or I want it to start heating something, or to do something like that. You could do that. And we're really making it easy for everyone to build their experiment around this this interface. Let me show you a video. I think next, yeah. So this is the video showing a bit of information about the box itself. So as I said, input and output, if you want to, you can control whatever you want inside the box. There is power already provided because we have batteries on board, which is going to be safe. You have a programmable controller, which is quite powerful actually, and you can use for your experiment, or you can bring your own thing if you want to. There is a real-time link, which is going to be mainly for telemetry and telecommand. So if you want to, from ground station, send some information or command it to do something. And then you have a very easy software integration. So you can code your application in C or in Python using LabVIEW. Yeah, so as I said, like really the idea of this box is to provide you everything you need, and you can just focus on your science. That's the idea here. And it's not just a 3D render, because so this was when we were assembling it. So you can see that it actually physically exists. You can have a sense of the volume. So this is the smaller version, but you can have a sense of the volume of that you have available for the experiment, and then all the electronics that goes into. So usually, instead of you starting to come up, with, okay, what battery do I need? Which microcontroller do I need? How am I going to record the data? How am I going to make sure that it's going to be safe? We have been designing and implementing everything, and it's going to be integrated inside this box. and it's going to be really a turnkey solution for you. You can just come with this box, and then you just connect it to our power and data line, and you'll be perfectly fine. So where we are right now, as I said, so we started by designing and building a flight recorder that we used to measure a bunch of information about a flight with a glider. We managed to characterize that flight. We also built at the same time a pilot display, because we want to be able to calculate what the pilot needs to do so that it gets the perfect parabola. And we've done, actually, we have improved a lot since the paper that we published, the standard deviation about the for the level of gravity that we reach, a level of acceleration that we reach. We also build this rack just to make it easier for people to come just where they experiment. As long as it fits inside the box, they're going to be fine. They can use our power line, they can use our data link with the ground station, and we actually flew it a lot of times, and we've been working on the operation, both with for safety and both to improve the quality of those measurements. So this is really what the platform can do. And if you are interested, there is a call right now. The deadline is March 1st, so you still have a month, a few weeks to look into it. But don't, if you don't have, what you need to do is really fill a form online on the website. So you go on LIDE.space. There's going to be a form that you can fill, and really don't worry if you don't have a perfect, fully designed idea yet. Just come, write your idea, and we're going to be selecting some teams based on their ideas, and then we'll be helping you to integrate it and implement it inside one of our Lightbox. So if you have a cool idea, just fill the form with your idea. You have a few weeks, and if you win, actually, so we'll be helping you implement it. So we'll be supporting you. SELGRA is there's a grant to cover your trip and accommodation for the flight day, which hopefully is going to be during the summer. And then you're going to have a full day of flight with Lightspace, which can be very interesting as well. So you can basically have a free few days coming to Belgium and flying it at our aerodrome, at our headquarters here in Belgium. Hopefully in the summer, there's not going to be there's going to be less issues with traveling. And then, yeah, so just go on the website again. We can probably check it together. I can show you the website. And if you have any question, just feel free. Either on Twitter, you can email, message us at Lightspace or at Space Mode. So that's me. Or you go directly on the website. You can also email us, me, or info@light.space. I really strongly encourage you. So you go on the website and you're going to see this pop up. You click here, and this page is going to open, and I strongly encourage you to have a look and see, and you can go. You have a bit more information here. There's again the link to the paper and the practical guidelines, and then you have this application form to fill. And yeah, so if you have any question, if you let us know. Otherwise, I'll be here with Camille to answer any question that you might have about gliders and microgravity.
Great, thank you very much, Mohammad. So yeah, maybe we can welcome also the other LIDE team members to the conversation now. Depending on the question, maybe some may be able to answer more than others. Yeah, actually, it's a really exciting platform, really exciting opportunities. And you were talking about the grant offered by SELGRA and by LIDE to fly student experiments. Yeah, I think it's a great opportunity to have first experience in microgravity. And also, you were mentioning, like, even if you don't have a final idea, try to apply to fly your experiment. Something else also, SELGRA also is meant to be a community about students interested in microgravity. This means that even if you are alone, you feel like you have an idea, but you don't know how to implement it because you are alone and you need team members. Then just write something on the Facebook SELGRA page, or write us so that maybe you can find team members who would be interested in your experiment, who could help you. Maybe you have a good experiment in physics and you need an engineer to help you to integrate your experiment in the glider. So just don't be afraid. If you have an idea, just you can try. So we actually had already a couple of questions during your talk, Mohammad. So maybe I will start with these questions. For the others, if you have additional questions, don't hesitate to ask them in the chat. So the first one is from Malika Schmidt. So apparently she's also a glider pilot. I didn't know that, but she is a little bit concerned about weather conditions, especially important because I think she's based in the UK. So how often do you think you are able to provide the number of parabola and the quality of microgravity? Because she said some flights, depending on the conditions, can be only a couple of minutes.
I don't know. Is DG or is it just Kemi who's on? Because we have our pilot. I don't know if he was going to.
He's here.
I'm here, Mohammad. I'm here.
Yeah, I think it's mostly a question for Denis Gabriel. Yes.
Yeah. Can you hear me fine?
Yep.
Yes.
Okay, right. So thanks, Malika, for the question. And as a pilot, I totally understand your concern. And thanks, Jeremy, for that piece of context. I understand better your question since you're based in the UK. So basically what we need for the parabola is much less than what you would need to really fly your glider in optimal, let's say optimal soaring conditions. So we can really, so we still need to be in VFR flight, but you know, there are a lot of days over the year where you wouldn't fly your glider if you intended to, let's say, make a nice flight, do some distance or duration flight or whatever. Here, really, the purpose is just to have this 15, let's say 10 to 15 minutes flight where we can accommodate up to 15 parabolas. And basically we're not flying thermals with the gliders. We will just be towed at the required altitude and perform the flight and then land. That's basically how we have been doing that. And for that, I mean, you really need less or not that optimal weather conditions. You just basically need 1,000 meters of ceiling and VFR conditions. And this is, so I have no clear answer to, I mean, quantitative answer to how often, or because it really depends on the location, but I can tell you that from where we operate in Belgium, there's gonna be a great amount of days where we can accommodate a flight. And yeah, I mean, that's basically how we envision this.
Okay, thank you, Denis Gabriel. I take the opportunity that you're still here to ask you another question that was asked during the presentation. It's about the timeline of the parabolas. The question was about, so you did it yourself, all the figures you give about the timeline of the parabolas are with you piloting, right? Do you need a lot of training to be able to reach this, or can any pilot do this?
Yeah, so the maneuver itself is not really complex, but to reach a certain level of quality, you certainly need training. And so I've been actually in the glider, but not flying. We've been working with a couple of pilots which are qualified for this. And the point that since you train these people, you want to keep them doing the maneuver because they really improve over time. And I think Mohammad mentioned that a couple of times during the talk. Now regarding the timeline of the parabola, it's pretty clear on this figure. So you always have these 6 seconds of microgravity, which is the green region on this plot, which is followed by 2 to 3 seconds of acceleration where the gravity level comes back to about 1. So that's the blue region. And then you have a let's say hypergravity region where you actually transition from a dive to an upward going flight so that you can start again the next parabola. And this also lasts about 3 seconds. So this is really that cycle that lasts for 10 to 12 seconds, where you have 6 seconds in microgravity, 2 to 3 seconds about 1G, and then a pull-up section where you can reach basically 3 to 4 Gs during 2 to 3 seconds.
Okay, thank you. So maybe I have an additional questions because you were talking about hypergravity. I think one of the real advantages of the glider and the solution you have is also the modularity of the flights. Since you don't have 20 experiments flying at the same time, you have a bit of modularity and you can adapt to the experiment that is inside. Some experiments are very sensitive to hypergravity. And my question is, have you tried to do like half parabolas? So rather than going up, doing your parabola and then going downwards, you try just like start of flight and then drop the glider so that you skip the first hypergravity phase?
So yeah, that's a good point. We have not tested such maneuvers, but we have the way we envision it is more having a dedicated flight for that, which would not be based on any parabolic trajectories, but you can easily reach higher level of gravities by just entering a steep turn with the glider. So we didn't perform any test with that, but this is actually much simpler because it's actually even part of any glider pilot training, just doing it a steep turn and recover from it. And so it basically means that it's fairly easy to reach levels up to 3 to 4 Gs and for actually long durations. And this is also something that we can accommodate. I mean, we've been essentially focusing on parabolic flights because it's maybe harder to realize, and we felt like there is more demand for that type of flights. But actually, it's completely open, and we can really design the flight profile to what's needed for the experiment. So we're open to work with any of the participants to really tailor the flight to their needs.
Great, thank you very much. So maybe I'll come back to Mohammad now. I have an additional question from Malika, saying that maybe one of the advantages of this kind of opportunity and this kind of platform also is that it would be possible to fly with a researcher in the back seat of the glider. She asked if you envision to have this kind of experiments with an operator on board the glider or not.
So it's something that is possible at the moment, but it wouldn't be possible at the same time than having the experiment rack. So if the observation that the researcher wants to do is, for example, like something that they're wearing on themselves, like I'm thinking about, like maybe they have some bio sensors on them and they want to measure something on themselves about this, something biological, and they want to see if something changed within those 6 seconds of weightlessness, or maybe during the hypergravity phase just after. Obviously, they could do those measurements on themselves when they're sitting on the back. At the moment, the solution that we have doesn't allow the researchers to be on the back and having the experiment rack at the same time on the back seat. But again, these are exactly the type of questions that if you have, just message us on Twitter or email us and then let us know what you're thinking about, and maybe we can help you and we can find something. If it's just because you want to fly on the glider, that's also a good reason why to apply. Because for sure, the winner are hopefully going to have the opportunity to fly on the glider themselves. If not, once we have the experiment done, there's probably going to be a time to to fly yourself on the glider. So
okay, great to know. Maybe I'm gonna apply then. I had
so I can see that there are some questions about like they're talking about the type of experiment. I saw that someone asking about if medical experiment are possible. So Camille is our chief scientist. Maybe you can say, because I know you've been looking into a lot of different applications, and maybe you have some ideas that you can share, Camille, about what is possible with the glider, and maybe inspire some people here.
Yeah, definitely. So we had a question about the possibility to perform medicine and health-related experiments on board the glider. So from the top of my mind, I don't see why it would not be possible. When you perform parabolic flights with a glider, you have obviously two main caveats. The first one is the shorter time of microgravity that you have compared to engine-based aircraft or to sounding rockets. So this limits the use of gliders to the study of phenomenon with kind of a short time constant. Typically, you won't be able to study plant growth or plant biology on board a glider. And the second caveat is the narrow space that you can access. You only have access to the narrow space of the backseat of the glider. So if your experiment is about, I don't know, robotics and brain-computer interface, it's probably going to be quite difficult to implement it. But apart from this, apart from this limitation, it's completely possible to perform medical experiments. I recently saw a paper about a team of students who studied, I think, the permeability of the cell, of the membrane of some cells in a drop tower. So with quite a short time of microgravity. So if you have small samples, and if you are looking for studying a phenomenon with a short time constant, it's perfectly possible.
I think there was also one other question in the chat, which was maybe Mohammad, if you can come back after this nice video to the rack that you have, because the question was about the maximum volume that you can take.
Yeah. So again, it depends on the experiment. So if your volume is higher than what we have here, you can always talk to us. Because it depends what it is. So our risk assessment, basically in our operation manual, assumes that so this box needs to be hermetically sealed, and so that's basically the limiting factor of the volume. If you have an experiment that requires if it requires to be inside of this for any reason. If not, then obviously we can see if the volume can be higher and leave it open, for example. It would really depend on the risk assessment. The way we try to do this, because we wanted to have a standardized interface, both mechanical and electrical, as I said, with our rack. So the volume that you have is going to be, this is basically the size, so 20 centimeters by 22 by 34. So that's about the size of this. I think a big. Oops. I think a bit. Yeah, I think about the size of a bit higher than this. So this is something that was. We have a bit more room than this. But you could fit this, and so yeah, if your experiment fits in something like this, it's going to be fine. If you need higher, then it would depend on the risk assessment, and if you need it to be in a hermetically sealed environment or not. So depends, if it's something that's loose, if you have liquids involved, if you're gonna have a heat source involved. So maybe the best thing is just to give us as much information as you can in the form, and then we'll come back to you. And if there is anything we can change to make it happen, we'll definitely do that. And if before applying you want to be sure about it and you have some questions, again, feel free as well, and just message us. I don't know if the person has any specific idea about the type of volume that they had in mind.
It's not specified, but
okay. But I mean, once you have an idea, just let us know. Otherwise, all the information is on the website.
Great, thank you. Maybe a tricky question because it certainly depends on the type of experiment. But do you have an idea of how much time you think you need between the concept of the experiment and the actual flight of this experiment? It definitely depends on the design that you require in terms of engineering, but do you have an idea maybe?
I think it can be very short. So, for example, like we're working with an actual like a company in Belgium that I cannot disclose it, but really they're looking at phase interface in microgravity for some reason, and the manipulation, like you don't need to have something super fancy, and you don't even need to use our microcontroller. So what they wanted to see is something that can be checked visually, and they're gonna have their do I have something? No, they're gonna have their liquid this mixture liquid in a small tube, and they're gonna have a GoPro, I mean a camera looking at it, and they're gonna just be filming this interface, and that's it. And whenever it's in microgravity, they're gonna get the result. They're gonna have a timestamp. They're just gonna sync it with their camera, and they will just visually see what happens to this liquid interface when it's in weightlessness. And that's what all they were interested in. So something like this, I mean, as I said, so we're offering you a data link and power, but you don't need to use it. If you just want to put, if you have a small, fun thing that you just want to put in front of a camera and film it in microgravity, you can. Our slogan is really we're trying to democratize access to microgravity for education, science, and fun. I mean, if there are artists who have some ideas, they want to see something happening in microgravity and they just want to film it, they can. If your scientific experiment just requires, a visual recording, you can do it, and you would just put your camera, you record it on the camera, so you don't even need to code anything on the microcontroller, and that's it. So that would be as simple as putting what you want to film, sticking it in somewhere in this box, and then putting, I don't know, maybe even your phone, and you're filming it. So it can be as simple as that. What we try to offer is some kind of like standardized generic experiment rack where you can maybe do a bit more. So you can get power if you want to, and you can get it in a safe way, and you can use even ground station link. So our link, what I showed you, was very low data rate link, because it's mainly used for telemetry and telecommand. But again, if you don't need telemetry because you're just going to record everything on either on our microcontroller, or you're just going to put a camera there, then you don't need to interface that at all. And if you have your own batteries, you don't need to use our power neither. It's available if you need it, but if you don't, you don't. So I think it can be very easy. It depends on your ideas. I think as everything in science, probably finding the creative idea is the hardest part, but it could just be a camera filming something.
Yeah, actually, sometimes the simplest experiments are the best sometimes. I have an additional question now. It's about also the possibility to interact with the experiments, for instance, between two flights. Because, for instance, if you launch your experiment on a sounding rocket and you forgot to switch on the power button, then you cannot do anything. Is it possible? I mean, how easy is it for you to access the rack with the experiments between two flights, to change something and to put it again in the rack in the back seat and fly again?
Yeah, it's actually quite easy. So the way the box was designed, and so DG was actually supervising the whole design part of the hardware. So maybe he can add something, but the whole idea is that you can open it and swap payloads. So even on the day of the flight that we have, there might be there's going to be two teams of winners, and one of them, once we've done one experiment, we're going to try the other one, and it's going to be as simple as swapping one for the other one. Definitely, if there is something that went wrong, you can easily open it and see what's inside. This is also one of the reasons why we offer you the possibility of sending telemetry data to our ground station, like in a wireless way, so you could check from the ground if something is wrong or not, and send commands. Like if you need to turn it on, you could do it with a command from the ground station, but that's entirely up to you. The design is made so that the swap is easy. Did you want to add something, or was good?
No, you're just fine. Yeah, we thought the whole thing in terms of modularity, and I think with respect to other solutions, as you mentioned, one of the advantage here is that you can really tweak things in between two experiments and go back to fly, and really in a short turnaround, you know. So yeah, that's the way it's supposed to be. Yeah.
Perfect. Then, do we have additional questions? If so, then maybe you can ask your questions in the chat. If not, yes, Mohammed mentioned that you can just email him or use Twitter to contact him or to contact the rest of the LIDE team. So are there any other questions or any other comments from the LIDE team maybe?
Well, from our side, we're super excited about this partnership. I think we are, so the goal of bringing microgravity research to more people definitely is aligning with what ELGRA and SELGRA are trying to do. So thank you very much for your support for this project. And I hope that some people by listening to this and watching our videos, they now have some ideas and they will definitely apply. So we're looking forward to your applications. And if you have any question or if you're doubt and you're not sure, just email us or DM us on Twitter and we can work it together.
Great, thank you very much. Yes, again, yes, don't hesitate to if you have any idea, even if you don't have a team of students that have the same interests as you can always find people that are looking for ideas like yours in the SELGRA community. So just share your ideas with us. We can help you find a team. We can help you also integrate on the LIDE platform with the LIDE team. So yeah, I know you have a lot of imagination, so I'm pretty sure you can find exciting ideas. We are waiting for your application up to the 1st of March, I'm correct?
Yes, correct.
Yes, so up to the 1st of March, so still 3 weeks, I guess. This webinar will be accessible again on YouTube. So even if you missed the beginning, so you can still see it on YouTube. Again, if you have additional questions, you can ask us. Thank you very much to all the LIDE team, Mohammad and Gabriel, Camille. Thank you also to all the attendees of this webinar. I think it was pretty exciting. And I'm looking forward to see all the goals of LIDE to be accomplished in the future, to have more experiments available for students, cheaper experiments with a shorter lead time. Pretty exciting for the future. So thank you again, and I see you in the next SELGRA webinar. Bye-bye.
Thank you. Bye.